So that is what that. This one cancel is equal to 180. That is equal to 180 divided by pi. You will write degrees, radians to degrees. For example, 10 radians have to be converted to degrees. What you will do? And therefore 10 radians. 10 radian. A plane angle is equal to 10 into 180 divided by pi. 10 into 180 divided by pi. Any number of radians to convert into degrees, what you have to do? You have to multiply with 180 by pi. In this case, degree to radians, what you will write? You will multiply with the pi by 180. You will multiply. This is the conversion of radians and degrees. Very important. And go through this. This is very, actually, we have the beginning topic. They are only very, very basic. Not so important for examination point of view, but this for knowledge point of view, these are all very, very important. So this is about supplementary quantities, right? So we have two kinds of quantities we have said, which are the fundamental quantities and the derived quantities. What are fundamental quantities? Those quantities which are independent. Independent means they do not want the help of any other quantities for the specification, are called fundamental quantities, also called as base quantities. Earlier we had three fundamental quantities, which are the length, the mass, and time. When science advanced, the number of fundamental quantities also increased. How many fundamental quantities now we have present? At present, we have 7 fundamental quantities by heart. Length, mass, time, electric current, temperature, right? Then luminous intensity, quantity of matter, all this, right? In all, how many? 7 fundamental quantities and 2 supplementary quantities. The other one is what is called solid angle. Solid angle is from a surface of a closed solid body. If a certain area is marked, that area, just like a parachute. Parachute, parachute you have, there is a surface there, and there are so many strings are coming from the circumference of the top, the roof, and it is coming to a central point. At the central point, an angle is made. That is called a solid angle, right? So from a large body like this, right? If you take an area here, and this area will subtend an angle at this point, and this angle is called omega, is called what is called solid angle. Suppose like you have an object, a spherical object, just like a pumpkin is taken. Okay, a sharp knife also, a long sharp knife also taken, right? Okay, then you do one thing: pierce the knife such that through the surface, and such that the end goes to the center of that, and just turn it and take out a part, just like a kulfi, just like the eyes, the kulfi and a kulfi. That means there is a surface, and also there is a solid part. It is tapering, and it is finally ending at the center. The angle made at the center part, end part, is what is called solid angle, right? This is the surface. This is surface. Surface most of the time represented by ds. A small surface is always represented by ds. ds is actually ds is area is a scalar quantity. The quantity is scalar, and vectors also will talk afterwards, right? But this ds is a very small area. This is said as surface vector. Its magnitude is area itself, area of that much part, and that has a direction also. That direction means the direction of the surface vector is perpendicular to that area, is what is called surface vector, right? So surface vector has a direction as well as a magnitude, right? By this term ds, I mean a very small value of area. Understand? So this surface vector will subtend an angle at the center of the whole body. This is a solid body. Solid body, that means a covered solid body. At the center, any shaped body, right? We can take. But we will take a small area out of this. That area, from every, that means the peripheral point of this area, we will extend radiate toward the center. So at the center, a solid angle formed. This is what is called a solid angle, right? Solid angle is denoted by omega. General expression for omega is ds cos theta divided by r square. ds cos theta divided by r square. The detailed study of this is not necessary for physics students, right? In mathematics, when the teacher teaches you these things, solid angle and plane angle, then he will teach you in detail, right? Omega is equal to ds cos theta by r square. This is general expression for theta can be equal to 0 and also can be any angle, right? When theta is equal to 0, this can be necessary special condition. Omega is equal to ds by r square, where r is the radius and ds is the magnitude of the area which subtends the angle at the center. So omega represents a solid angle. Solid angle, general expression. You remember this formula. That is only necessary for physics students. Omega is equal to ds cos theta divided by r square. This is a general expression for that. And the special equation is theta when is equal to 0, then omega is equal to ds divided by r square. If it is a very large area, if it is a very large area, then what will happen? Very large area means, suppose a large area A is there, that substance an angle. What angle? Solid angle at the center is equal to A divided by R square. A divided by R. If it is a closed body, the entire area of the closed body will subtend a solid angle is equal to. Closed means a spherical, you take a sphere, right? The sphere as a whole has an area equal to 4 pi r square, right? In that sense, a spherical body, a closed surface, what is the solid angle subtend the center? So, for a spherical body, the area of the whole surface is what is called 4 pi r square. Everybody knows that. Divided by r square. R square cancelled is equal to 4 pi stir radians. 4 pi stir radians. Stir radians. 4 pi stir radians. So, a closed surface of a big body of any shape, does not mean that there must be a spherical body only. No, any body that has a volume, but that closed surface, then the solid angle subtended at the center is equal to 4 pi stir radians, right? So this is what you call the uh, solid angle. So solid angle is a very important term, right? Solid angle is measured by using a unit called stir radians, right? The definition of stir radians, you will look at the book and you will write in your notes also that everything is not taught anywhere in the world. Something is left for you also as a definition. So this is about a solid angle. Solid angle is the angle subtend a certain area of a body at the center of that. General expression for solid angle is omega is equal to ds cos theta divided by r square. If cos theta is equal to 1, the value of solid angle is given by omega is equal to ds by r square. If the area is very big, the large area at the center of the whole body, the angles of the solid angle subtend is given by a divided by r square. If it is a closed body, just like a spherical body, the whole area of the spherical body is equal to 4 pi r square divided by r square is equal to 4 pi. So generally we can say that a closed body, a big body, having a large area of any shape at the center of which the whole area of the body will subtend an angle, a solid angle is equal to 4 pi stir radians. So closed body, the total value of solid angle subtended at the center is equal to 4 pi stir radians. So these are the things I taught you today. So we have started from physics. What is physics? We have said physics is a branch of science that deals with matter and energy, and also all the physical material around you. The study of that is called physics, and also it deals with the physical quantities. What is a physical quantity? Everybody knows. Physical quantity is something or any quantity that can be measured are called physical quantities. So many physical quantities also I have said, right? Now these are the basic ideas I told you. Then tomorrow we will talk about more about units and the systems of units and all, right? Thank you very much today. And tomorrow we'll start with a new lesson. Okay. Have a very nice